incorporate, think
Okay.
of them as groups.
Animation.
Yeah. All right. So hi, everyone. It is a pleasure to be here today. I'm Hannah Spungen. I'm a former EM resident from UCLA, currently at Banner University studying toxicology. I'm here to present our presentation, Completeness and Spin in COVID-19 related RCT preprints on medRxiv. So this has been conveniently addressed pretty thoroughly already, but to summarize, there was a huge increase in the volume of preprints related to COVID-19 that came out, just around the beginning of the pandemic. As you can, there are a bunch of different preprint servers, but as you can see here, medRxiv is shown in pink, and there was that has emerged as one of the most popular, actually the most popular preprint server for disseminating COVID research, and there was a huge increase in the volume of preprints that were disseminated with the pandemic. So these preprints have gained the attention of clinicians, the media, and lay people, but there have been some unintended consequences. As Dr. Davidson was discussing just now, there were plenty of examples of treatments like hydroxychloroquine or ivermectin being incorporated into COVID treatment protocols on the basis of preprint information that later turned out to be flawed or disproven. So there's real potential for harm here. Now, because this is such a broad landscape for our project, we decided to focus only on abstracts of preprints that were published on medRxiv and only on RCTs. So our aim was to describe the publication history of these medRxiv COVID-19 RCT preprints and to characterize their completeness and their spin. And in doing so, we hope to shed some light on the potential harms of preprints and to evaluate the impact of peer review on abstract content and spin. So first, we identified all the COVID-19 RCTs on medRxiv in a 2-year time period that spanned from December 2019 to December 2021. For our search strategy, we partnered with a UCLA librarian and we supplemented the native COVID-19 specific database on bio and medRxiv with other strategies like intervention-specific searches. So I initially identified 291 preprints and ultimately included 236 of these. So the substrate of our study, let me see if this, there we go. So the substrate of our study were the abstracts that you see at the bottom here. So we found of these 236 preprints, 161 of them had associated publications, and 75 did not. So of those 161, we blinded all of the abstracts, the preprint version, the published version, and then obviously the ones that didn't have associated publication were blinded only in preprint format. And we ended up with something that looked like this. So this was prepared for us by research assistants who weren't involved with the scoring, and they processed each of these abstracts into an identical format. So one of these is a preprint version, one of these is a published version, and ideally you wouldn't be able to tell the difference between the two. We did some things to kind of help enhance the blinding, like removing some of the subheadings, which we thought might be a little bit too journal specific. So after each abstract was scored individually by one of 3 reviewers, the reviewers were given pairs of preprint published abstracts that were in a random order. And textual differences between the documents were highlighted, as you can see here. And reviewers indicated which had better completeness and which had more spin. So it was a Likert style scale, greatly favors A, etc. So this is our scoring tool. For completeness, scoring completeness, it was fairly straightforward. We just adapted from Consort for abstracts. And we did a couple of rounds of practice scoring just to improve inter-rater consistency. We also developed a guideline document that had examples for each score to reference. For relative spin scoring, we used criteria based on work by Boutron et al. And spin was scored in the results and conclusions section only. Though we specified which category of spin was counted for each item where applicable, these distinctions were collapsed into a binary present or absent score for the purposes of the analysis presented today. So using these scoring tools, we divided our work into 3 phases with respect to scoring. In part 1, 3 reviewers independently scored all 236 abstracts for completeness using the consort-based scoring tool. And in part 2, the same reviewer was given each corresponding preprint published pair. So that was the slide you saw earlier of the head-to-head comparison. And scorers reported which of the blinded versions did a better job of fulfilling the consort criteria and which had more spin in each category. And in part 3, the 75 preprints with no associated publication were compared to a random sample of 75 preprints with the associated publication. Oh, sorry, next slide. So that is part A here. And then these 75 preprints with the associated publication were compared to their published counterparts. And all were rated on a single Gestalt level of spin scale of 0 to 10. So as far as our results, this slide is intended to clarify the timeline of the included preprints. In green here, you can see the date of medRxiv posting, and in blue, you can see the date of journal publication. And the difference between the 2 lines represents the volume of unpublished preprints. Sorry. The timing of unpublished preprints is shown here in black, and this figure demonstrates that even in the most recently published, posted unpublished preprints, there was 5.2 months in between posting and our final publication search. So when you look at the histogram on the right, you can see that the vast majority of preprints that do go on to be published are published by the 6-month mark, and vanishingly few are published after 9 months to a year. So this is essentially to say that we think that we had a fairly adequate follow-up time. It's possible that there were still some preprints that went on to be published that we didn't identify, but for the most part, we think our search window was adequate. So the demographics of the preprints we found, the majority dealt with pharmacologic agents followed closely by vaccines. The herbal or natural supplement category had the highest rate of unpublished preprints, followed by miscellaneous, and this included things like light therapy, vagal nerve stimulation, or magnetic field related studies. The most common specific pharmacologic agents studied were shown here. And as you can see, most of the convalescent plasma trials were published, but contrast this with ivermectin, where 4 of the 7 we found remained unpublished. You can also see that overall the preprints that remained unpublished tended to have smaller number of participants. So these are the results of our completeness scoring using the consort criteria. There's essentially 0 differences in some of the categories you might expect, like interventions or conclusion, just because it's hard to write an abstract without these. But you can see some more dramatic differences in some of the other categories. And specifically for trial design, objective hypothesis, primary outcome definition, and primary outcome results, these are the categories where we saw a substantial difference between the unpublished preprints that's shown as black dots here, and the published cohorts and the preprints that went on to publication. And interestingly, among these categories, the preprints that did go on to publication, which are in gray, scored a lot closer to the published versions than the unpublished abstracts. So overall, it suggests that peer review modestly and incompletely improves completeness, at least on a few of these axes. So in part 2, for selected completeness, which is on top here, and spin, which is on the bottom here, categories, one reviewer looked at the blinded side-by-side preprint published pairs and rated whether one was greatly superior to, equal to, or inferior to the other. We found that when these differences exist, they universally favored the published abstract. There's considerably more blue than red, though, as you can also see, for most categories, except maybe consensibility, no difference was the most common verdict. So for these graphs, these are the distributions of absolute spin using a Gestalt 1 to 10 scoring system. And the take-home message here, sorry, I'm running low on time. The take-home message here is that there was substantially more spin in those preprints that went on to be published I'm sorry, more spin in the preprints than those that went on to be published, and these more highly spun abstracts were therefore the ones that don't get subjected to peer review. And this is a graph of the not the quantitative spin, but from a scale of 0 to 10, this graphs the preprints, the preprint and its published counterpart. And as you can see here, as the graph progresses from left to right, the most of the articles that had changes went from the gray dot to the preprint is the gray dot and the published version is the red dot. The vast majority of them saw an improvement in their spin score with publication, though there were a few that had increased spin after publication. So there were plenty of limitations to our study. These were abstracts only, not the full text. It was a single subject matter and trial design. And our follow-up period was finite, but like we were talking about earlier, we think that it was adequate at least. And the conclusion, the main takeaway here is that the less comprehensive and more highly spun preprints were more likely to remain unpublished and therefore uncorrected by peer review. So it modestly and incompletely improved the content and decreased spin in preprint abstracts. So thank you so much, and we'll take any questions or comments now.
Thanks, Hannah. Questions? Let me start with one. One of the characteristics of medical journals, as opposed to journals that publish other sorts of research, is that they are publishing for an audience that includes clinicians who are not researchers, as opposed to the AI that we heard about, which is being published for AI researchers, and the researchers have the ability to therefore have the ability to critique the research themselves. So did you have any sense of the articles that were being changed, where the abstracts were being changed, despun, or some of the some of the completeness or respun? Were they have any sense of who they were intended for? Was their intended audience a sophisticated audience that could despin themselves, or was it the clinician who was going to be prescribing Paxlovid?
I think that it's hard to answer because they were so heterogeneous in their quality. Just anecdotally, many of these were clearly posted as preprints. Some journals encourage preprint posting around the same time as publication. Those were the ones that you didn't see a lot of change in. Those I think were more left as standalone, left for the reader to decide on their own. But in some of the other ones, especially some of the ones that had more spin, I think they were. My impression was that the spin functioned to make it more publishable, and regardless, without any sort of intention one way or the other to the audience interpreting.
Thanks. Back there, then up here.
Yeah, I'm Mike Brown, Cochrane and Michigan State University. I'm having trouble reconciling your presentation with the previous presentation, because the previous one showed how the numbers in the preprint versus the published version pretty much stayed the same. Gave me some sense of reassurance that the preprints were maybe valid. But then your presentation shows that there's all kinds of preprints that are never even make it to publication. So can we even, believe that, especially when they're incorporated into living systematic reviews very quickly? So if you have a comment on that.
It is concerning, though. I think it's still internally it's still, I think, consistent, because an example of the slides are gone. I had a couple of example slides, but basically, they might have had the same numeric results, but if there was a non-statistically significant conclusion and the conclusion started focusing on the secondary outcome and had more emphasis in that would be reflected more in our paper than the numbers itself.
Thanks. Up here, then in the back.
Anna Marušić, Croatia. Thank you. This is interesting study. We know that abstracts don't represent may not represent what is in the article, but I would like to ask you whether you think this is COVID specific, or did you have a control to show that it's different for COVID, this changing than for other articles that have preprints and published articles?
I think that would be a really important, topic to study in the future. Fortunately, I mean, for our purposes, the COVID pandemic and the explosion in preprint use happened at the same time. So it would even be, I think it would be hard for us to separate one from the other, but I think it certainly would be interesting to look a little bit further down the line and see, if this holds true for other subject areas.
Back, then front.
Thank you. Jennifer Byrne, Australia. I was interested in the preprints that remained unpublished and whether there might have been any sort of systematic differences in that group. For example, they might have represented preprints that were abandoned because they duplicated preprints that might have come earlier and were published. Was there any sort of evidence of that?
I was actually surprised by the quality of the ones that did go on to be published in many cases. It's hard to make sweeping generalizations about them, but for the most part, I would say they were the non-pharmacologic intervention trials. Sometimes they were some of the behavioral intervention trials, and conversely, the vaccine-related trials seem to have a fairly high level of, unsurprisingly, a fairly high publication level. So those would be a few off the top of my head of the trends that I can speak to.
Hi, Mario Malichki from Stanford University. I was wondering if you could clarify a little bit what you said, that you think that spin is used to increase the chances of publication. If these were all posted as preprint with they're already published, I mean, as preprints, therefore there's no requirement how you write your abstract that will delay your publication. Did you mean for a journal that if you make it more spicy, it will more likely be?
Yeah, essentially, I think, or it's a way of kind of touting your own results and making it seem like your work is more meaningful or significant than it is.
So the overspin can not be a help. Go ahead.
Robert Thibault, Stanford University. I'm wondering, reducing spin, obviously a good thing, increasing reporting of consort items, obviously a good thing, but you showed that most remained unchanged. So if you think of it in a number needed to treat fashion, maybe you need 10 peer reviews to increase one reduction of spin. Do you think that effort is justified to reduce, small amounts of spin, or if people just left their preprint, or if we didn't have to go through such a rigorous or long peer review process and just went to the next project, would that be more efficient use of researchers' time?
I think that in order to figure out where the resources need to be focused the best, we would need more data that's broken down by specifically which journals we're seeing the trends in, because I think this is a pretty heterogeneous population. Some of these are, it can be published in a journal with an impact factor of 0 or close to 100, these certainly the ones that are published in some of the, the pay to publish or kind of the lower impact factor journals, not that that's a great proxy for quality, but I'm just kind of using it as shorthand here. I think those are the ones, that it would be worth looking at more closely, the specific breakdown, which is kind of what we're hoping to do kind of moving forward, is stratify some of these findings by the publication quality measures.
Thanks. In the back.
Hi, I'm Charlotte Kent. I'm with CDC and the editor-in-chief of MMWR. A question I have as you're delving into this more, and especially as you're thinking about spin, have you ever looked at like altmetric scores with some of the things in medRxiv? Because I know some of their scores for some of the preprints are very, very high, and it might be especially interesting to look at the spin aspect of it.
No, we haven't done that yet, but I'm taking notes here because it sounds like a great idea for future direction. Another thing that we were thinking about looking at was, you can update which version of an abstract you have in medRxiv. So we were kind of torn as to how to handle, which of them is visible for longer. Does the content change with each version? And that would be another great way to see exactly what the potential damage out there is being done.
Okay, thank you.
To put it pessimistically, yeah. Thanks.
Anyone else? Well, with that, I think we're done. A really terrific session.